All right, here is a sample test that we're going to work through. Always with test taking, I encourage you to work on problems that you think are easiest first and come back to some of the harder ones. But since I wrote the test, I feel comfortable with all of these, hopefully. So, all right, so find the derivative, do not simplify, okay, of this function. So I see that it's a sum and difference of a couple functions. So I'm just going to take their derivatives individually. Arctangent of x, or sorry, arcsine of x squared. Hopefully we've got that formula written down or memorized. It's du, where u is my x squared, over the square root of 1 minus u squared, x squared squared. Plus e cubed, the derivative of e cubed, it's a constant, so don't get fooled by that. That's just 0. Minus cosecant of pi x. The derivative of minus cosecant is positive cosecant cotangent times the derivative of pi x, which is pi. And here we have another little chain rule 1. The derivative of this is 5, 4 minus 3x to the 4th times negative 3. Derivative of the inside. No simplification, so I'm going to stop there. Number 2, let f of x equals x squared sine x. Find the derivative at pi. This one is written as a multiple choice question, but you still want to show your work. There's no real disadvantage here, the multiple choice. It's only an advantage because your correct answer is one of these. So I need to find the derivative. This is a product. So derivative of the first times the second plus the derivative of the second times the first. And I evaluate that derivative at pi, which is 2 pi sine of pi plus cosine of pi times pi squared. Hopefully remember from the unit circle, right, that pi is here. So sine of pi is going to be 0 because the y value there is 0. So that whole thing goes to 0. Cosine of pi is minus 1. So I get minus pi squared, which luckily is one of our answers. Okay, find and simplify this derivative. So right, I pay attention to the simplify here, and otherwise it is just a derivative, which is a quotient rule. No easy way to simplify this algebraically. So I do low d high minus high d low all over the bottom function squared. Right? Don't multiply out the bottom function. That's fine. That's simplified. But the top, I've got to work out a little bit. So it's going to be 2x squared plus 6 minus 4x squared minus 6x. So I get minus 2x squared minus 6x plus 6 over x squared plus 3 squared. You can pull a 2 out of that or a minus 2 out of that if you like. I wouldn't. I wouldn't care. Pulling out constants, not changing the structure too much. So either one of those would be good answers. This one is a little nicer. So I'm taking a look here. And at this point, it's never a bad idea to sort of take a look at the length of the test and just make sure that you're on track time-wise. Okay, find and do not simplify the derivative. So this is a natural log of u, effectively. So it's going to be the derivative of the inside over the inside function, arctangent of 2 minus x squared, That's the inside function. That's my u. So I need the derivative of that up here. The derivative of arctangent is du. Arctangent of u, this is like an inside function, is du over 1 plus u squared. Okay. Derivative here, this is secant to the 5th. I've mentioned this in class sometimes that you may prefer to write it like that. It's more clearly a power rule when it's written like that. So it's 5u to the 4th times the derivative of the inside. This is sine of something, so the derivative of that is cosine of that something times the derivative. The derivative of 3 to the x is 3 to the x times the natural log of 3. In here in part C, we have an implicit function. I can see from the ways the x's and the y's are mixed up. So I need to find the derivative implicitly. When I take the derivative of the first, that's going to be a product. Derivative of the first times the second. 3y squared times dy dx, right? Every time I take the derivative of y, I get dy dx. The derivative of 5 is 0. And this is 1 over 2 square roots of y times dy dx. It's like the square root of u derivative. So now just a little bit of algebra to solve for dy dx. I have 2 terms with dy dx, so I'm going to move this piece over here. And factor it out. Right, so I moved this piece over and then pulled the dy dx out at once, and then I'm going to divide both sides to get this derivative here. So that's y cubed divided by 1 over 2 square roots of y minus 3x y squared. Get no simplification needed because we're not supposed to simplify. All right, part D here, I notice this one is a function of x raised to a power involving x, so that needs logarithmic differentiation. I take the natural log of both sides, and that allows me to take that x and move it in front as a product. I take the derivative of the natural log of y implicitly, and then I use my product rule here. Du, derivative of tangent, or natural log of tangent, is du over u. So dy dx, then when I multiply by y, that's tangent of x to the x times the natural log of tangent of x plus x secant squared over tangent. Oops, sorry. That. I'm just having people here to tell me when I've written off the screen. This secant squared over tangent could be simplified a little bit, but again, not needed. Okay. Okay, so again, there's a couple multiple choice ones here. No big deal. It's really just find the second derivative of this function. So we start by finding the first derivative, 2x times the natural log of 2x plus x squared times du over u derivative. Now, I would like to simplify this a little bit before taking the second derivative. 2x natural log of 2x is fine, but this, right, the 2's cancel and one of the x's cancel. X. Right. Anytime I take the derivative, I do want to simplify first. Even if the question doesn't ask me to simplify, because it's going to make my life easier when I take that derivative. So here I take the derivative of this. This is another product. Derivative of the first times the second plus the first times the derivative of the second. Du over u plus 1. Again, notice a little simplification here. There's 2 plus 1, which is 3. So that's 2 natural log of 2x plus 3. That's good because that is one of our selections here. Here, again, notice the reading. I mean, we are in like automatic derivative mode here, but the derivative here is used to help us find the equation of the tangent line. So don't get distracted and just focus on the derivative. This is another quotient rule. Low d high minus high d low all over low squared. I'm putting in the point 0 for x. So I get cosine of 0, which is 1. Who cares what this is because it's getting multiplied by sine of 0, which is 0. So that's all going to go to 0. And cosine of 0 again is 1 squared. So this all equals 5. Remember, that's the slope of the tangent line. I notice, right, this one looks possible, but we got to verify that, make sure that really is the point. Well, it is my y-intercept, right? 0, 3. So slope is 5, y-intercept is 3. That is that one. Okay, here's a implicit function again. Right, y is mixed up there. So when I take the derivative of this, this is going to be a chain rule. But when I take the derivative of xy, remember that's a product rule. Derivative of 5 is 0, so I get dy dx. So here I have to be a little careful solving for it because I want to distribute that. So I get y e to the xy plus x e to the xy times dy dx equals dy dx. So I can move this over and factor out the dy dx. 1 minus x e to the xy. Moving that term over and then factoring it out. So when I divide, I get y e to the xy divided by 1 minus x e to the xy. And let's hope that I've got one that looks like that. This looks like it. Let me just verify. Looks good to me. Okay. So the tangent line to this curve has the equation here. So I'm trying to find the equation to the tangent line. Now notice here there's a couple, well, there's one kind of bad answer, right, which is A. This is not a tangent line, right? This, if you multiply this all out, this is some sort of cubic function, right? Definitely not a line. So there's no way that's the solution. The others are certainly possible. They all look like lines of some sort. So y prime is 3x squared minus 4x plus 2. Right, we should all love polynomials at this point in our calculus journey. And I'm interested at 2, 5. So I'm going to put in 2 here, which is going to give me 4 times 3 or 12 minus 8 plus 2, which is 6. So the slope is 6. These are all in the kind of point slope form. So if I really was uncomfortable with that, I could kind of simplify them down to y equals mx plus b form. But this is y minus y1 equals mx minus x1. This is the correct result here. So this last question here, we haven't covered. That's from 3.9. So we'll wait on that one. But hopefully you found something helpful in there looking through those derivatives.